everyone. I'm happy to meet you for the first time here. This is zullah Özgür, one of the master students of Yıldız Technical University in Computer Engineering Department. Today, in 9th International Conference on Signal Processing and Pattern Recognition, I want to present my master thesis project presentation. My topic is authentication in ATM or ITM machines using iris biometrics. Some years we left behind that iris recognition systems are being used for national identification and entitlement distribution. So this is about the automatic identification of persons by their iris patterns. You know that this is one approach to a more general subject. I call it biometrics. Identification, of course, rely either upon special positions like cards or keys or documents or passports. Other positions are securities that belong to a person, like PIN numbers or passwords. Of course, what of these can be forgotten or stolen by others. They can be lost also. So the idea behind biometric identification of persons is some automatic method that relies on something very unique. Ideally, it is very complex in their anatomy or in their behavior or in their physiology. Going through the recent literature, the Bank United of Texas developed a iris scanner to do transactions without using any kind of card, but only iris biometrics, using a face detector along with a face recognizer and an eye localizer. In order to facilitate transaction without ATM card, they utilized the biometric of iris by brightening iris by IR light to capture the iris image at distance of 20 and 30 centimeters. By comparing 4 well-known algorithms, I decided to go on with Daugman iris recognition systems. Referring to the academic papers, Daugman algorithms accuracy much higher. We have found out that Daugman algorithm can enable the implementation of iris biometrics in a faster and more correct way compared to other algorithms. This will allow ATM or ITM users can comfortably access their accounts and make transactions without the need for a card or PIN or password, while authenticating their identity in the machines using their iris biometrics. Relating to the identification, all monozygotic twins are almost identical. They are hardly known from each other, even for the first time facing to them. They appear indistinguishable. There are many researches around the world for identical face demonstration did not work terribly well. If we look at the images, we can claim that inter-glasses variability and intra-glass variability problems are genetic phenotypes in face. Also, their duplicators are problems. And the other very important concept is that people look indistinguishable from each other. For this kind face recognition, basically will not work. These are just a small set of collection of duplicators who are photographed by philosopher Bernal, and they seem to be almost they are hard to distinguish. So if I jump from facial recognition ideas to iris properties, that we can find out iris is an organ located inside of eye, behind the cornea, behind the aqueous humor, in front of the lens, and in front of the retina. In the back, it is highly protected, meaning it is not genetically correlated, not genetically determined, although in color, which of course is genetically determined, and it as far as the evidence available tells us it is stable apart from some pigmentation changes, while occur often, but color does not play any role in the iris recognition. Our iris and pupil detected by the Daugman operator. Once the iris outer border is detected, pupil is center coordinates are found by searching the 10 times 10 neighborhood, the image showing the different circular contours at a range of radii. Integral differential operator that finds all these boundaries, and they are sort of curvilinear edges. So think of an edge detector that's allowed to be curvilinear or operating the circular coordinate. The internal different find the maximum of a derivative of counter integral tells you where these edges are fairly reliably. You cannot assume over that they are circular. The iris boundaries are often non-rounded. These are non-circular iris coordinates. Another issue here is eyelashes. They include much of the iris, eyelid. Eyelid is some upper, and eyelashes come down, and so they have to be excluded from the important part of iris. Early years, the iris recognition systems were not as convenient, and sometimes it was not user-friendly as it might or should have been. It was not like in the picture like this. And nowadays, the situation you can see in the image is not valid. Iris recognition systems are capable to acquire iris in a proper manner. When going to the airport, it is you had to get close up to the camera, and nowadays, of course, this has become a much more fluid and user interface with captured standoff distance of often about some distance. It is rather more convenient and fluid than something like popped up in previous slide. Example of importance, high entropy, as in all pattern recognition problems. The key issue is relation between interclass and intraclass variability. Objects can be reliably classified only if the variability among different instances of a given class is less than the variability between different classes. For example, in face recognition, difficulties arise from the fact that the face is a changeable social organ, displaying a variety of expressions, as well as being an active three-dimensional object whose image varies with viewing angle, pose, illumination, and age. United Identification Authority of India in 2011 started to enroll iris images of citizens. As of November 2015, it became 9,700 28 million people erase patterns saved to database. Comparing to FAI database, it is 20 times larger than the total FAI database. When enrolling, the erase pattern is compared against all of these enrolled so far. To detect duplicates, cross comparisons daily, it is about 900 trillion. Finding an erase in an image to capture the most details of erase patterns, the imaging system should have minimum 70 pixels in erase radius. Resolved erase radius of 80 up to 130 pixels has been more typical. Very often the pupil center is nasal and inferior to the iris center. Its radius can range from 0.1 to 0.8 of iris radius. There is a project pocket and diagram showing that the first part showing that ATM interface, and second one is showing the interface of bank API. When the input is captured from in front of the ATM, then the image features extracted and sent to the bank API to authenticate whether it is a correct person or not. And this is the interface of my project that I created. I deployed it in Python, and for registration we need it is identity, name, surname, and biometrics into database. When we save it, the Daugman algorithm calculates, computes the features and saves to the database correctly. In this stage, that the ATM or capturing some customer's iris image and his card into the ATM code gain to carry out an authentication operation. So we can say that successfully compared by the features of the iris. If the features of iris is not matched or not correct, the time it will pop up a error message that the iris pattern is not matching. Thank you for your attention. If you have any question, I will try to answer them.